All right, for this video, I'm going to talk about direction cosines and direction angles, and how to find those and what they mean. Okay. The direction angles are denoted by alpha, beta, and gamma. And I'll draw those in a minute so you can understand what those angles are. Okay, but first, we have to talk about for any vector v, because it'll be the direction angles for any vector v. When you write a vector, you write that as a lowercase bold v. That means it's a vector. And then when you write the three components, v1, v2, and v3, these are scalar values. So v1 is the scalar value of the x component. Scalar value of the y component is v2, and the scalar value of the z component is v3. Okay. Now, let's look at what this looks like for a specific vector. So let's take vector v, and let's say our vector is 2, 4, 3. I'm just going to end up in the first octant. Okay, the first octant means all three components are positive. So when we draw this with the x, the y, and the z, and we know this is going to end up in the first octant in this space right here in front of us. Okay, so if the x component is 2, the y component is 4. Draw it this way, that's going to end up there. And the z component is 3. So we'll go up 3. I'm drawing a box just so you can see dimension a little bit. Okay, so this vector is the vector that starts back here at the origin and ends up here. So closer to us than the YZ plane that ends up here. Okay? Now, to define your alpha, your beta, and your gamma, alpha is the angle made by any vector v with the x-axis. It's this angle right here. Call that alpha. Okay? You can see this doesn't lie. Alpha is an angle on a plane formed by the x-axis and our vector v. Okay? Any two vectors can just define a plane. So you're looking at a plane that you can't see here. It's not the xz plane, it's not the xy plane, it's not the yz plane. It's a plane that would be formed kind of going up this way. Okay, kind of like a slanted thing. Now, if we're going to attach this to make a triangle, draw this triangle here. Now, it's hard to see here, but this side of the triangle is the x-axis. This side of the triangle lies on this plane up here. Okay? So the x-axis and this plane are perpendicular. So right here, you actually have a right angle. And this angle in here was alpha. So the cosine of alpha is equal to your adjacent, which is this value is 2, over your hypotenuse. Okay, notice this isn't the hypotenuse. This right here is the hypotenuse. So the hypotenuse is going to be the absolute value of our vector v, which is the square root of 2 squared plus 4 squared plus 3 squared. Okay, or the square root of 4 plus 16 plus 9, and that's the square root of 29. So 2 over the square root of 29. Okay, so that is the direction cosine for alpha, cosine of alpha. Now I'm going to draw this again so we can find beta. Beta is similar, but it's the angle formed by our vector and the y-axis. Okay, so I'm going to draw this again over here. Draw the same box so we can kind of see over here where this lies. It's really hard to draw this. I want to draw 3 pictures so we can see the difference. So we've got this thing right here, and if you take this thing, the set vector v, and this angle right here, that's beta. Okay, so that's the second one. It's the angle formed with your vector, wherever your vector is, and the positive y-axis. Now this, notice, this is another plane. This would lie on a plane over here. Okay, kind of. If you took a piece of cardboard here and then had it kind of hold the bottom here and have this come towards you, you get that plane. Now we're going to draw this triangle here. And notice the y-axis is perpendicular to this side. So therefore, the y-axis is perpendicular to any vector that lies in this plane. So this right here is a right angle. Okay? So the cosine of beta is going to be equal to adjacent, which is this value, 4, over square root of 29. And the final picture is going to be gamma. Now then you can guess, this is going to be the angle formed with your vector and the z-axis. So here's your vector coming up this way, and then your z-axis. Okay, if you wanted to look at what plane this is, this would be a plane over here. This right here, this angle is your gamma, which looks like a funny looking y. Okay, and if you made a right triangle here, you would see this would be your right angle. Okay, and the cosine of gamma would be adjacent over hypotenuse, or adjacent, which in this case was 3 over rad 29. Okay, now just to simplify these a little bit, what we really did here, and to generalize, cosine of alpha was equal to, notice where this 2 came from, okay? The 2 was the v1, the x component of our vector. So that's just your v1 over magnitude of v. The cosine of beta is equal to the v2, the 4 was the y component, over magnitude of v. And then cosine of gamma was the v3 over magnitude of v. Okay? Now, going back, so I want to show you one more thing. When we find the magnitude of the vector v, the way we find a magnitude of a vector, we do the square root of this component of your v1 squared plus v2 squared plus v3 squared. Okay, so we're going to look at another property of your direction cosines. What happens if I take cosine squared alpha plus cosine squared beta plus cosine squared gamma? Okay, well, let's see. Cosine of alpha is this thing. So if we're going to square this thing, that's going to be v1 squared over magnitude of v squared plus cosine squared beta is going to be this thing squared, v2 squared over magnitude of v squared plus cosine of gamma is this. So when we square it, v3 squared over magnitude of v squared. Notice we already have common denominators. Okay, so we can put these all together, magnitude of v squared. We have v1 squared plus v2 squared plus v3 squared. All right, well, let's go up here when we just talked about this. The magnitude of v is this thing. So the magnitude of v squared is equal to, get rid of the square root, v1 squared plus v2 squared plus v3 squared. Oops, sorry, that should be a square. Okay. So now if we replace this, which is in our numerator, with this, okay, this thing, which is in our numerator, well, this thing was just equal to the magnitude of v squared divided by the magnitude of v squared, and that's equal to 1. So this is something that is true, always true, about your directional cosines. Okay, now let's look at one example from the book. Let's look at example 4. So in example 4, it says find the direction cosines and angles, the direction angles for the vector 2i plus 3j plus 4. 2i, oh, that's almost the one that we just did, but it's 2i plus 3j plus 4. Okay, or you can call that vector 2, 3, 4. Okay, So your direction cosines, your cosine of alpha is just this over the magnitude of v. And if this thing is v, the magnitude of v is going to be square root of 2 squared plus 3 squared plus 4 squared, square root of 4 plus 9 plus 16, which is the square root of 29. Coincidentally, that has the exact same magnitude. So cosine of beta is equal to your v2, which is 3, over square root of 29. And then the cosine of gamma is equal to your v3 over magnitude of v, which is square root of 29. Okay. Now, if you want to find your actual angles, alpha, you just have to do cosine inverse of this. And that comes out to 68.2 degrees. Beta would be cosine inverse of 3 over rad 29, which is 56.1 degrees. And gamma is cosine inverse of 4 over rad 29, which is 42.0 degrees. So that's it. There's not a whole lot to this, but it is something you probably haven't seen before. It's not super intuitive. Oh, I was going to show you one more thing. Let's see. So this thing right here, here's another picture I found online to look at your direction cosines. So here's your V that comes out into quadrant 1 for any vector. Alpha right here is the angle formed with your positive x-axis and your vector. The beta is the angle formed with your vector and the positive y-axis. So here's beta. And then gamma is measured from the positive z to your vector. So there's gamma. So I don't know if that's helpful, more or less helpful. I like to draw it this way just so you can see a little bit better. You can see the dimensions. But either way. Okay, well, that is it for this lesson.